Alright, sometimes the perfect squares factors are not as obvious, so it can be helpful to use this other method of listing the prime factors. Okay, if we're talking about 216, it's not immediately obvious to me what goes into 216, so we start out like this. 216, and we're going to start with the smallest prime, which is 2, and 2 goes into 216 108 times. Does 2 still go into that? Yes. So 2 goes into 108 54 times. This is kind of like an upside down division problem. Then 2 goes into 54 27 times. Since 2 no longer goes into that, we're going to start with the next smallest prime, which is 3. 3 goes into 27 9 times. 3 goes into 9 3 times. And 3 goes into 3 once. And we do this until we get a 1 at the bottom. That's when we stop. But you keep going until that number is a 1. Now what we do is look for pairs. 2 times 2 is 4, so that's a perfect square. And 3 times 3 is 9, so that's a perfect square. So we have, in 216, we have the square root of 4 times 9 times, and then you had these two other ones left. 2 times 3 is 6. So we have the square root of 4 times the square root of 9 times the square root of 6. The square root of 4 is 2, times the square root of 9 is 3, times we can't take the square root of 6, so it just stays 6. So we have 6 times the square root of 6. This may be confusing the first time you hear it. There's a lot to it, but once you've done it a couple times, it becomes a pattern that you just repeat. Let's do this with 150. We still start with 2. Does 2 go into 150? Yes, it goes in 75 times. 2 doesn't go into 75, so we try 3. 3 goes into 75 25 times. 3 doesn't go into 25, so our next prime is 5. 5 goes into 25 5 times. 5 goes into 5 once. Now we know to stop. We have a 1 at the bottom. We look for our pairs. 5 times 5 is 25, so this is 25 times. We have our two oddballs. 2 times 3 is 6. The square root of 25 is 5 times the square root of 6. So 5 times the square root of 6. 512. All right, we're going to start with the square root of 512. So we start with our smallest prime, 2. 2 goes into 512. 256 times. 2 still goes into that. So 2 goes into 256 128 times. 2 goes into that 64 times. 2 and 32. 2 and 16. 2 and 8. 2 and 4. 2. 2 and 1 more 2. There we go. We end at 1, and we're looking for pairs. So we have 4 pairs, so we have the square root of 4 times 4 times 4 times 4 times 2. So the square root of 4 is 2, the square root of 4 is 2, the square root of 4 is 2, and the square root of 4 is 2. And then we leave the square root of 2 inside. 2 times 2 is 4, times 2 is 8, times 2 is 16, so this is 16 square root 2. This one has a negative sign outside. It's a strange odd number, so a lot of times you'll want to say that it doesn't have anything that goes into it, but always check. There aren't going to be any even numbers that go into it, so the next thing we want to check is 3. 1 plus 4 is 5, plus 7 is 12, so 3 does go into it. 3 goes into 49 times. 3 doesn't go into 49, and neither does 5, but 7 does. 7 and 7 and 1. We stop at 1. We have a pair here, so this becomes negative the square root of 49 times 3. The square root of 49 is 7, so negative 7 times the square root of 3. Do the same thing here with the square root of 80. I think you guys have this. 240, 220, 210, 2, 5, 5 and 1. Always go until you reach 1. Don't stop with the number down there. We have 2 pairs of 2, so the square root of 4 times 4 times 5. So the square root of this is 2, and the square root of this is 2. So 2 times the square root of 5, 4 times the square root of 5. You do the same thing with 384. We're going to go on to looking at variable expressions. Any variable that has an even exponent is a perfect square. So the square root of x squared is x. The square root of y to the 6th is y cubed, because y cubed times y cubed gives you y to the 6th. So this is y cubed. Basically what you're doing is taking, if it has an even exponent, you're going to take half of that. Now on this one, the square root of y to the 8th is going to be y to the 4th. But when you have x cubed, you need to break that up. X cubed is equal to, and you look at what is the next even number down from 3, which would be 2. So that's going to be x squared times x. What that does is break it up into a perfect square times something that's not a perfect square. So this, let's erase this. This would be x squared times x times y to the 8th. Now we have our perfect squares. The square root of x squared is x. The square root of y to the 8th is y to the 4th. And we leave the square root of x inside. This one we have not, this is a perfect square. X to the 4th is a perfect square. Y is not a perfect square, but there's nothing we can do to it because its exponent is 1. So the square root of 9 is 3. The square root of x to the 4th is x squared, and we leave the square root of y inside. Let's go ahead and do the one below that before we hit the fractions. The square root of 80 we just did on the last page. So let's look at that again. We had the square root of 80 was 4 times the square root of 5. So that means 80 must be 16 times 5. We'll just shorten that since we've already done it. X to the 5th, we're going to go down an exponent, x to the 4th times x. Here are our perfect squares. The square root of 16 is 4. The square root of x to the 4th is x squared. We're left with the non-perfect ones inside, 5x. Alright, when we're looking at fractions, we always want to simplify the fractions like we did before. Both of those are divisible by 5, so we end up with 9 over 1. X cubed goes into x to the 6th, x cubed times. So negative 9x cubed. Alright, now that we've simplified our fraction, we want to keep going. 9 is already a perfect square. With x cubed, remember we go down an exponent and times x. Now we have our perfect squares. Square root of 9 is 3. The square root of x squared is x times the square root of x. And you noticed our negative just followed all the way down. Alright, on this one we're going to simplify our fraction. It's still negative. 2 goes into 32 16 times. X goes into x to the 4th, x cubed. You end up with a y squared on bottom. Right, now this x cubed needs to be split up. So that becomes 16x squared times x with y squared on bottom. When you take a square root of a denominator, it works exactly the same way, but when you pull it out, remember that it's still a denominator to a fraction. So we have negative, the square root of 16 is 4, the square root of x squared is x, over the square root of y squared is y, and then times the square root of x, because that was on top. Alright, try these, and we'll discuss them in class.